Hi, hello everybody. So this is section 27, properties of logarithms. And before we actually go into the properties dealing with this section, let's just recap a little bit what was covered in the previous section. So in the previous section, we introduced the concept of what a logarithm is. And I have three examples here. Um, the concept was we have this new log function, and the log function uh, always has a base. Okay. And the base has to be a number that is positive, but not one. So any positive number other than one serves as a base. Now, when we evaluate the log of something, like in this particular case, we say or we read this as log of 8 base 2 or log base 2 of 8. We're looking for an exponent that we're going to raise the base to 2. So the question can be translated into this. What number you can raise to 2 in order to get 8? Okay. And obviously that answer is 3, right? The reason the answer is 3 is because 2 to the third power is 8. So you would write 3, and here's the explanation. 2 to the 3 is 8. Now take a look at the next one, right? Again, we're looking for an exponent that 3 can be the base of in order to get a 1. Right? So in this case, the answer is 0 because 3 to the 0 is 1. And the last example, log base 2 of 1 over 16. So I'm looking for an exponent that I raise to 2 in order to get 1 over 16. So you kind of know that it has something to do with the number 4, right? Because 2 to the 4 is 16, but this is 1 over 16. So in order to get 1 over 16, all I have to do is move the 4 to the denominator, or I can write the 1 over 16 as 16 to the negative 1. And now the 16 can be changed to 2 to the fourth raised to the negative 1. And that would be 2 to the negative 4, right? So then the answer to this is just negative 4. And here's the proof. 2 to the negative 4 is 1 over 2 to the 4th, which is 1 over 16. So this is what we did the last section, right? Now we're not going to be evaluating these logs here directly because we've already done that before. So if you need to review this a little more, with the examples that we've done, you can do that. But for now, let's focus on the three properties that we have to cover. The first one is right here, the product rule. Okay, so the product rule is the following thing. So the log of any base of a product, so this is what I'm talking about right now, is the log of the first element plus the log of the second. Now, this is if I'm going from left to right. If I'm going from right to left, is the opposite, right? So log of a sum is the log of a product going in this direction. So when we have a product, we turn the log into a sum. And when we have a sum, we turn the log into a product. But the the second option here at the bottom, it's only applicable if the bases are the same, right? So you have to keep an eye out for that. So the bases have to be the same. All right. The second property is the quotient rule, which is pretty much the same as the product rule, but we have a minus in the middle. So the quotient rule going from left to right is log of a ratio, x over y, is equal to log of the numerator minus log of the denominator. And if I'm going in the opposite direction, log of a difference is equal log of the ratio, x over y. But again, provided that, and pay close attention here, the bases are the same. The bases are the same. I can turn the difference into a ratio. Otherwise, I cannot. And notice, very, very important that you notice that it's log of the ratio, but not log bx over log by, right? So pay very close attention is not the entire log of x divided by the entire log of y. It's the log of x over y. It's very different. Okay. So that's the second property. And then the third property is what we call the power rule. So if I have the log of something raised to a power, then that exponent or that power leaves the exponent and goes and multiply the log itself. Okay, so this is going again from left to right. And if I go in the opposite direction, right, any number multiplying the log goes and becomes the exponent of the variable or number you're trying to take the log of. So those are the three properties that we kind of have to know in order to do the problems associated with this section, which will be basically two types of problems. Okay, so these are the three properties. Now, the two types of problems that we are going to be responsible for are right here. Okay. They are problems where we are going to get an expression and we are going to expand the expression. Now that means we have a single expression in terms of log and we expand it into multiple individual expressions. Or we are going to condense a log, meaning we're going to start with multiple terms with logs, and we are going to convert into something that has a single log expression. All right. So let's take a look. So here's the first example. And we're going to apply either the concept of evaluating logs, or we're going to apply the properties of logs. So we're going to use these two concepts to either expand or condense a log expression. So let's take a look at the first example that I have here. This is in your book or workbook. Uh, so in this case, let's expand, right? I have a single log expression and I have to expand it into multiple pieces. Now I have three pieces. I have 49 A and B, but the property is still the same, right? So because this is a product, you expand it the following way. Log base 7, 49 plus log base 7 of AB. And then you can reapply the product property again on A and B. So this is going to become log base 7, 49 plus log base 7a plus log base 7b. Now, log base 7a, log base 7 of b, there's nothing else that you can do, but take a look at log base 7 of 49. I can see, or I have to check, if this can be evaluated using the basic definitions of log. And sure enough, it is, right? Log base 7 of 49 is actually 2 because 7 squared is 49. Now, remember, the definition is I'm looking for an exponent to 7 that equals 49. So 7 squared is 49. So then you would have to write as your final answer 2 plus log base 7a plus log base 7b. And that would be the answer for that one. The next problem is exactly the opposite. So we're not going to expand this. We are starting with two log expressions. So we want to condense the log. So this is the product property in reverse. Now, this can only be worked if the two bases are the same. So they are the same, log base 6. So I can write them this way, log base, not 3, 6. Log base 6 of 3 times 2. Now, obviously, this is log base 6 of 6. And now I have to see if I can evaluate log base 6 of 6. So again, I'm going to write it over here for you to see. So that expression means which number I can have 6 raised to in order to get 6. Well, obviously the answer is 1 because 6 to the 1 is 6. So log base 6 of 6 is 1. So this expression here is 1. All right, so this is what you're supposed to do. So applying the properties of logs, and the first property was the product rule or multiplication. Okay, so let me just scroll back up for you to see. So here's the product rule. And now we're going to apply the quotient rule in the next set of problems. So that's with the minus right here on the upper right. So let's take a look at the next problem. Right? We'll do this problem. Now recall that whenever a log does not have a base, so I wrote this over here as a reminder, recall that there are two special bases, 10 and E. Base 10 logs are called common logs, and base E logs are called natural logs. Now, in the case of common logs, we don't write them this way, for example. We don't put the base. We just write log of 3. So if you do not see a base, then that means that that base is 10. This is pretty much like the radical, right? If we have something like this and you do not see an index, the default is 2. It's the same with logs. So that's a base 10 or common log. Now, in the case of natural logs, we don't write them this way, log base E. Okay? We have a special notation for that, and that is ln, natural log. So if you see ln, that means this is a natural log, which means the base is E. All right, so now that we recall this information, let's see if we can do these problems right here. Just going to erase this. So you don't see a base, so the invisible base is 10. You don't have to write it there, but that's what it is. I'm just writing here for you to see. So this is log base 10 of 100 over t. So applying the quotient property in reverse, this would be an expansion. I'm expanding the logs. This would be log 100, log base 10 of 100, minus log base 10 of t. So notice I don't write the base. We just leave it blank because it's understood to mean 10. Okay? Just erase this here. Now, there's nothing I can do with log base 10 of t, but this can be simplified, right? Again, this is 10 to some exponent equals 100. So what is this exponent? Oh, it's obviously 2, right? Because 10 squared is equal to 100. So this has to be simplified to log base 10 of 100. It's to be simplified to 2, and then I would write log base 10 of t. Okay? So log base 10 of 100 over t is this. So this is how we expand the expression using the quotient rule. Now, the next case, because I'm starting with two terms, I'm going to condense them. And remember, I can only do that if the bases are the same, which in this case they are again. Well, Professor, but what if I had something like this? Log base 3 of 36 minus log base 5 of 4. Well, then there's nothing you can do because the bases are different. There is something that you could do, and I'm going to show you at the end of this video, but using the properties of product, quotient, and power, nothing can be done. Okay, so since the bases are the same, I can apply the quotient rule in reverse, and that would be log base 3 of 36 over 4. And now I can divide 36 by 4. I get 9. And then I have to ask myself if I can evaluate or simplify this. So this means find me an exponent that goes on 3 whose answer is 9. Right? And obviously that answer is 2 because 3 squared is 9. So this expression is 2. Okay? So this is the quotient rule. Now, the last type of problem that we have to see is the one involving the power rule, right? When you have a log of something that has an exponent in there, or the exponent r is in front. Okay, so let's take a look at those examples. They are here in your textbook. Let's see those. We'll do the first one. Now, you see ln right here. This means a natural log, so it's log base e. We don't write it this way. We write it as ln. And we have first a ratio here. So we will apply the quotient rule, ln e, or log base e of e, minus natural log z cube. Okay. Now, this, I'm going to write it over here. This is actually log base e of e. Now, what is that? Now, this is similar to, for example, log base 7 of 7. Well, what is that? Well, this is 1, right? Because the exponent that goes here to get 7 is 1. Same thing. E to the 1 is e, so this answer is 1. So ln e is just 1. And now this part, the exponent by the properties of logs will go immediately in front of it. So this is going to be minus 3 ln z. Now notice, do not do 1 minus 3 equals negative 2, right? You cannot do that because the 3 is multiplying the log. So this is your final answer. The next case, let's take a look at the next case. Same thing, I have a ratio, and this is log base 10, right? You don't see the base. The default is common log or base 10. So this is going to be log square root of x minus log base 10 of y. Nothing you can do here, but this part, I can rewrite the radical as an exponent. So this is going to be log base 10 of x to the 1/2. You have to remember the conversion from before. I'm going to write it here to remind you. Okay, so we gave you this conversion before. This is the radical form. This is the exponential form. So radical x is x to the 1/2. So we have to write it that way, okay? Now this 1/2 by the properties of logs goes right there in front of it. So this is going to be 1/2 times log x minus log y. And obviously, if you wanted to, Professor, could we write, instead of writing 1/2 log x, could I do this? Log base x, everything over 2. Yes, you can do that. Minus log y. Now notice, do not do the following, right? This is correct, not the same log x over 2. This is incorrect, okay? So you either write 1/2 log x or log x over 2 as you see here. Okay, and the next and last set of problems, I think I copied the same thing twice. Let's just do one of them. It's the same. Um, let's condense this log expression, okay? Meaning I begin with multiple log expressions, and at the end, I have to have just one. All right, so let's see how that works. So the first thing that we do when we have, so remember, we have the product rule, we have the quotient rule, and we have the power rule, okay? When we have them all in one problem, the first one that we need to apply is the power rule. So there's a number here in front of the log. So this number goes and becomes the exponent of the x before we do anything else. We cannot do anything with the product rule until we do the power rule first. So that's going to be log base 3 of x squared. There's just a 1 in front of the log there, so that stays there because moving that 1 here is just the same x plus 1. So that would just be log base 3 of x plus 1. Okay. Now, at this point, you have to check to see if you can apply the product rule. And in this case, you can because the logs are the same, the bases are the same. If they were different, you couldn't do anything else and the problem would end right there. But because they are, then I can combine these two into one using the product rule. So this is going to be x squared, x plus 1. And this is my final answer. Okay. Now, let's do a variation of this. Let's pretend for a moment. Um, let's pretend for a moment that I had a 3 here and maybe a minus. Okay. Let's pretend I had this. So the first piece would look the same. Log base 3 x squared minus. The 3, not the negative, would go right here. Log base 3 x plus 1, 3. Now we check to see if the bases are the same. They are, but I have a minus in the middle. So now I apply the quotient rule. So log base 3 x squared over x plus 1 cube. And that would be my final answer. Okay? So it's very important that you understand when you have all of these three properties in one, the power rule gets to be done first. And then you either have the product or the quotient rule. Okay? And even if they appear at the same time, you can do one or the other first. It doesn't matter. But the power rule has to be done first. All right. So these are the three properties associated with this section 27. And there's only one more thing in this section, okay, that you have to know. In the event we cannot evaluate a log, right? Obviously, we have a calculator that we can use, but the calculator only has two types of logs. Most of the calculators, they only have base 10 or base E. Anything other than that, we don't have. So, for example, we could give you a question like, what is log base 10 of 17? Okay. Or just, we wouldn't write the base 10 here. We just would write log 17. Now, we don't know what that is because it's, not a single integer here. 10 to the 1 is 1, right? 10 to the 1 is 10. I'm sorry. And 10 square is 100. So I don't really know what exponent goes here to get 17. I would need the calculator. And you can use the calculator. So let's take a look at the calculator right now. So here's my calculator. And I have a log function, which is this key right here, log. And you can see that there are two logs, right? The log base 10, this log, and the ln, which is log base e. So all I have to do now is type in 17 right here, and the calculator will give me an approximated answer. Now, this is not the exact log because these decimals go on forever, but the calculator is only showing those many digits. So approximately the answer is 1.23. So if this is a question on the exam, you would just use the calculator and write approximately 1.23. Now, in the event that we have other bases, for example, take a look at these two examples. Okay, log base 3 of 56. Now, your calculator doesn't do that. And for that, we have this formula right here. Okay, you don't have to worry about it because if this is on an exam, we'll give you the formula. Or this formula is in the formula sheet that you can bring to the exam. So the log of any base of A is, you can pick any base you want, log base C of A, log base C of B. Or if you're using, this is the preferred formula with base 10. Okay, so log base B of A is natural log of A. I'm sorry, this is the base 10. Okay, this is the natural log, this is the base. It's the same, the answer is going to be exactly the same, but this uses the natural log, this uses base 10. So whichever way you want to do it. So log base B of A is log base 10 of A divided by log base 10 of B. Okay, so you can do that using this change formula, and you can use the main thing is now you can use a calculator for it. So for example, this question would be log base 10 of 56 over log base 10 of 3. And now the calculator can do, because we can do this and we can do that. Okay, let's take a look using the calculator what that is. Let's just move this over here so that we can see. So log base 10 of 56, right? You don't see a base, it's base 10 divided by log base 10 of 3. And the answer is approximately 3.66. Okay, so then you come here and you would write 3.56, 56, 66, whatever the answer was. 66. Okay. 66. So if this is a question on the exam, all you have to show is this part, right? The conversion. And then the final answer with is a calculator answer, because there's no way that you can do this. Now, don't try to guess what the number is. We don't want to see that. We want to see this part right here. Okay. Now, the last question will be, right, even if the bases are not whole numbers, we can still do it. This is perfectly fine. And using the base change formula, this becomes a trivial problem. So for example, this is going to be log base 10 of 3.5 over log base 10 of 1.8. If you want, you can use the natural log. The answer is going to come out the same and you can check. All right. So we can do that. So let's see what the answer will be. All right. So log base 10 of 3.5 divided by log base 10 of 1.8. Okay. Now, so the answer is 2.13. If you wanted to use natural log, the answer would come out the same. So here it is. Let's see. Natural log 3.5 divided by natural log. Obviously, use natural log for both. 1.8, and here is where you're going to see the same answer, 2.13. There you go. See, 2.13. So it doesn't matter if you use natural log or base 10 log. The answer is the same. Okay, so this is section 27, the three properties of logs, and this last formula, which we call change base formula.